that. So we have to look into how other branches of science are dealing with this kind of situation in which things are working, but they don't understand how they are working. I'm going to present an analogy from physics, and I believe that is not only analogy, but actually maybe the mode of action of homeopathy. But let's go and deep dive a little bit and look into that. So everybody is open, have open invitation to think and investigate further. So let's look into this analogy. Every time when you talk homeopathy, they say, well, it's so diluted, what about Avogadro's number? So when dilution reaches such a high that practically and theoretically there's no more molecule there, there's no more atom or molecule is left, how you're claiming this thing is working. So let's look into that. And in response, what I ask is, what about speed of light? And they become a little bit confused at that point, and then go further. Okay, so what is common in these things, this MRI and all the cameras, things like that? The commonality is quantum technology. And let's look into what is quantum technology. Let's do some baby steps. I'm not a physicist, but I'll try to understand and explain the best I can do. So this is an interview by John Francis Clauser. He won the Nobel Prize last year on working on quantum physics. And in his interview, they kind of give a little bit history of quantum physics. That in 1930s, Einstein and others were very, very confused and perplexed with phenomena of entanglement, which required two separate particles remain connected without direct contact. So one thing is 1 mile or 10 mile or 100 mile away, and these two particles coming from the same source are able to communicate with each other instantaneously. And Einstein famously called it spooky action at a distance, because they were communicating faster than the speed of light. So in one question, the interviewer asked him that we hear that your idea of testing the principles of entanglement was unappealing to other physicists. Can you tell us more about that? And he says that in 1960s and 70s, experimental testing of quantum mechanics was unpopular at Caltech, Columbia, UC Berkeley. So basically everywhere you cannot work how this quantum thing is working. You just have to do it and believe it. And he says that my faculty at Columbia told me that testing quantum physics was going to destroy my career. So I cannot explain as good as this professor from England explained. So I'm going to Professor Jim Al-Khalili. He had a long video and I made it in a few minutes out of that. But every word he's saying is such a, a golden word that we need to listen it and understand it, what is being said.
It's hard to overstate just how crazy this is. Bohr was effectively claiming that one can never know where the electron actually is at all until you measure it. And it's not just that you don't know where the electron is. It's weirdly as though the electron itself is everywhere at once.
Bear in mind that electrons are among the commonest and most basic building blocks of reality. And yet, here's Bohr saying that only by looking do we actually conjure their position into existence. It's like there's a curtain between us and the quantum world, and behind it, there is no solid reality, just the potential for reality. Things only become real when we pull back the curtain and look.
And this view, ladies and gentlemen, became known as the Copenhagen interpretation.
Persuasive as it might seem, many people couldn't stomach Niels Bohr's outlandish ideas, and they found a natural leader in the most powerful man in science.
Albert Einstein hated this interpretation with every fiber of his being. He famously said, "Does the moon cease to exist when I don't look at it?"
Then, with two other scientists, Nathan Rosen and Boris Podolsky, Einstein thought they'd found a way to win the argument. He was convinced he'd found a fatal flaw in the Copenhagen interpretation, and its claim that reality was summoned into existence by the act of looking at it.
At the heart of Einstein's argument was an aspect of quantum mechanics called entanglement. Now, entanglement is this special, incredibly close relationship between a pair of quantum particles whose fates are intertwined. For example, if they were created in the same event. Let me try and explain this by imagining the two particles are spinning coins.
Imagine these coins are two electrons, created from the same event and then moved apart from each other. Quantum mechanics says that because they're created together, they're entangled. And now many of their properties are forever linked, wherever they are.
Remember, the Copenhagen interpretation says that until you measure one of the coins, neither of them is heads or tails. In fact, heads and tails don't even exist. And here's where entanglement makes this weird situation even weirder.
When we stop the first coin and it becomes heads, because the coins are linked through entanglement, the second coin will simultaneously become tails.
And here's the crucial thing. I can't predict what the outcome of my measurement will be, only that they will always be opposite. Einstein seized on this.
Because it meant that something was happening between the two coins that was almost too crazy to imagine.
It's as if the two coins are secretly communicating instantaneously across space and time, even if the first coin was on Earth and the other was on Pluto.
Einstein refused to believe this instantaneous, faster-than-light communication. His theory of relativity said that nothing could travel that fast, not even information. So how could one coin instantaneously know how the other would land? He disparagingly called it spooky action at a distance and claimed it was a fatal flaw in the Copenhagen interpretation.
The two entangled photons' properties couldn't have been set from the beginning, but are summoned into existence only when we measure them.
Something strange is linking them across space, something we can't explain or even imagine other than by using mathematics. And weirder, photons do only become real when we observe them. In some strange sense, it really does suggest the moon doesn't exist when we're not looking. It truly defies common sense. The experiment only confirms this. Whatever is happening, we just don't understand it. But it doesn't mean we should stop looking. And this is why quantum mechanics thrills and frustrates me. It's capricious, it's counterintuitive, it even sometimes feels just plain wrong. And yet, it still surprises us every day.
And I, for one, believe that our knowledge of the quantum world is still far from complete, that there are greater truths about nature yet to be discovered. And that's still what keeps me awake at night.
You didn't need to worry about the philosophical side of things to make progress with that. So, as you say, it really took a back seat.
Quantum mechanics led to a profound understanding of semiconductors, which helped create the modern electronic age. It produced lasers, revolutionizing communications, breathtaking new medical advances, and breakthroughs in nuclear power. Quantum mechanics was so successful that most working physicists deliberately chose to ignore Einstein's objections.
It simply didn't matter to them because it worked. They even coined a phrase for it: shut up and calculate.
And the price for this success was that Bohr and Einstein's debate on the reality of the quantum world was simply brushed under the carpet.
So let's see what kind of lessons we are learning from this professor's presentation, which we can apply in homeopathy. So look like scientists were divided into believers and non-believers, just like homeopathy. They kept using the principles of quantum despite not knowing how it works. So I'm using it, Dr. Imtiaz is using, we don't understand how it works, but we're seeing the results. So the lesson here is, do not worry about philosophical differences, how it works, why it works. Shut up and treat the patient. That should be our bottom line. Like the scientist says, shut up and do calculations. And research on contentious ideas, even if it is supposedly hurt your career, should not stop us from doing it. We need to keep doing the research. We need to keep looking into that deeper. And this spooky action in dilution, which is basically, the main objection they have on homeopathy, how this thing is working, it may be just very similar to quantum mechanics, that the actual molecule is gone, but somehow some kind of ghost molecule is still there, and that ghost molecule is doing something there. So we need to keep working on that. These ghost molecule ideas, or what other ideas you can come up with. So this is all open for debate and thinking. But the bottom line is, we should not stop working and using homeopathy if we don't understand. Look on the physics people, how did they do it?